Assalomu alaykum, hurmatli talabalar. Demak, bugungi kompyuter loyihalash fanidan ma'ruza matnini boshlaymiz. Demak, asosiy maqsadimiz kompyuter loyihalash fanida bo'lib o'tadigan loyihalash jarayonlarida qilinadigan ishlar haqida o'tiladi. Bu yerda asosan qilinadigan ishlarda qo'llaniladigan programmalar, ular strukturalari qanday tashkil qilinganligi va qanday loyihalash haqida asosiy tushunchalar va ayrim kichik video lavhalar bilan tushuntirib o'tishga harakat qilamiz. Demak, sanoat maqsadi bo'yicha, demak, MCAD Mechanical Computer Aided Design mexanik qurilmalarda kompyuter yordamida loyihalash, bular avtomobilsozlik, kemasozlik, aerokosmik sanoat va boshqa iste'mollar ishlab chiqarishda eng ko'p qo'shiladigan sapr tizimlari bo'ladi. Tarkibiy elementlariga asoslangan parametr bo'yicha, demak, dizayn bo'yicha, sirt bo'yicha va hajmni modellashtirish texnologiyalari qo'llaniladi. Demak, bularda bo'linishlarda o'zi jihatdan ham, demak, bular o'zlarini murakkablik darajasiga ko'ra 4 xil turga bo'linadi. Asosiy, demak, birinchi etapdagilar, demak, faqat chizma chizishlar uchun bo'ladigan programmalar va ularning murakkab darajasiga qarab, masalan, SolidWorks ili Katya programmalari, bular o'zi murakkab injenerlarga mo'ljallangan dasturlar hisoblanadi. YDAsi, demak, elektron dizaynni avtomatlashtirish yoki diqqat, elektron kompyuter yordamida loyihalash. Ya'ni elektron qurilmalarda, elektron uskunalarda, interaktiv mikrosxemalar, boshlang'ich platalarda boshlash uchun saprda Altum dizayn ili ORCAD degan programmadan foydalanadi. Bundan tashqari iCAD arxitektura, muhandislik va qurilish kompyuter yordamida loyihalashlar yoki CAD kompyuter arxitektura dizayn, arxitektura va qurilish sohasidagi sapr programmalardan biri bo'ladi. Bularda asosan binolar, sanoat obyektlari, yo'llar, ko'priklar va boshqa ko'pincha arxitektura qurishlar uchun qo'llanadigan programmalar. Bulardan sizlarga eng juda aniq ma'lum bo'lgani bu AutoCAD programmasi. Ya'ni bularda ichida yana ko'proq ishlatilayotganlari AutoCADda ichidagi kichik programmachilar sifatida AutoCAD Revit sayti, keyingisi Bend Icon degan programma hisoblanadi. Demak, belgilangan maqsad uchun ketadigan ishlarimiz uchun maqsadga ko'ra dizaynning turli tomonlarini ta'minlaydigan sapr yoki sapr quyi tizimlariga ajraladi. Demak, bularning ichida asosan bular saprga asosan CAD, CAM, KI, CAPga bo'linadi. Demak, CAD asosi kompyuter yordamida loyihalash. Ya'ni bularda birlamchi asosiy elementlar asosida bularning chizmalarni, geometrik shakllarni avtomatik holatda loyihalashdan iborat bo'ladi. Ya'ni CAD chizmalar loyihalash va yaratish, GAC esa geometrik modellashtirishdan iborat bo'ladi. Endi keyingisi KI tizimlari, kompyuter muhandislik. Yuqorida aytib o'tganimizdek, bunday muhandislik programmalarida asosiy hisob-kitoblar, murakkab hajmdagi yoki jismlarni kuchlanishga va ipirlantirishlarda dinamik ta'sir kuchlarini hisobga olgandagi loyihalashlar va ishlarni ancha optimallashtirish va yengillashtirish ilojini beradi. Bundan tashqari programma Computer Aided Analysis, kompyuter tahlili uchun foydalanadigan KI vositalarining kichik sinfidir. Bularga yuqorida aytib o'tgan programmalardan SolidWorks va Ensus programmalari, Tiflex programmasi hisoblasak bo'ladi. Bundan tashqari keyingi qo'yib o'rindagi CAM dasturlari, kompyuter yordamida ishlab chiqarish, mahsulotlarni ishlab chiqarish uchun texnologik tayyorgarlik vositalari yoki moslash uchun avtomatik ishlab chiqarish tizimlari bilan jihozlarni dasturlash, boshqarishni avtomatik ta'minlaydi. Ya'ni bularda asosiy raqamli dasturda boshqariladigan dastgohlarda sinflarga ko'ra avtomatlashtirilgan texnologik jarayonlarni loyihalash tizimlaridan iborat. Keyingisi bo'lsa kompyuter yordamida jarayonlarni rejalashtirish, ya'ni CAP. Sapr va CAM tizimlarini interfeysida qo'llaniladigan texnologik jarayonlarni rejalashtirish, avtomatlash vositalaridan iborat bo'ladi. Mana endi kichikina bir video faylimizni ko'rsangizlar, hozir ko'rsatib o'tsak bo'ladi bu yerda. Demak, prezentatsiyamiz ketish uchun hozir.
Push-pull++ overcomes various challenges of previous tools. First, new faces, shown in blue, can be inserted adaptively. Second, other adjacent faces, shown in green, are adjusted intuitively. Third, edges can collapse at locations marked by blue spheres. Here are two other example edits. Our adaptive face insertion algorithm can be configured by a threshold that determines if adjacent faces are extended or new faces are inserted. We also enable the user to select from multiple extrusion directions. Even complex geometry can be edited.
Mana chizmalarga qaraydigan bo'lsangizlar, mana asosan segmentlarga chiqarish, hajmiy ko'rsatishlarda mana shu programmadagi
We now show several examples of
qobiliyatlarni
how
ko'rsatib o'tilyapti. O'qlar bo'yicha va tekisliklar bo'yicha.
the goal is to keep these faces planar. This requires calculating and adding new vertices to adjacent faces. Note that we support vertices with valences higher than 3. In the following examples, we highlight the locations of edge collapses as blue spheres. We handle edge collapses locally without requiring Boolean operations. No self-intersections are created. With our push-pull ++ tool, faces and edges can be selected and transformed. Different directions can be chosen by hovering over the corresponding arrows. Blue arrows represent high thresholds. Here we show an example that is generated with the push-pull ++ tool. The user can split faces and use push-pull ++ operations without switching tools. Dragging edges allows rapid creation of slanted surfaces. In our evaluation, we compare our work to SketchUp and AutoCAD. We first show our solution. In SketchUp, the construction is significantly more complicated. Auxiliary lines need to be used. About 10 times more clicks are required than in our solution. Also, AutoCAD requires a lot more operations. Additionally, solid modeling operations have to be used. This requires about 7 times more clicks. Push-pull ++ overcomes various challenges of previous tools. First, new faces, shown in blue, can be inserted adaptively. Second, other adjacent faces, shown in green, are adjusted intuitively. Third, edges can collapse.
Demak, keyingisiga o'tamiz endi. Mana endi yana bir kichikgina solid kam bo'yicha darsda ko'rsatilyapti. Mana buni ham bir
solid
ko'rib
card,
olsangizlar
2.5D mill.
tushunarli
As
bo'lib
you can see,
ketadi
to
keyin.
start off,
Qanaqangi
we'll have to
qobiliyatlarga
look at
egaligi va bu
Not
dastur
onto
asosida
face was bounding box.
muhandislarga, loyihalovchilarga qancha
Face
yengilliklar
now
berishlari
start
haqida bu yerda
machine.
kichkinagina bir prezentatsiyamiz bor. Bir ko'rsangizlar, keyinchalik bular haqida batafsil yana mavzumizda gaplashib
Decide
olamiz.
depth I want to put to. In this case, it would be 0. From here, we can then go on to the technology. In the technology, we can pick from spiral, contour, or hatch. And to start off with, we'll use a contour operation. Adding fillets around the corners to stop high load on the tool. As you can see, if I simulate this, we can see the toolpath goes around twice and cuts exactly what I need. But if I wanted to change it, it's a simple click, going to contour to hatch, and you can see now I'm straight in with the toolpath I need to start facing off this job. Let's continue machining this by taking a pocket out of the middle. You can see on the toolbar I'm going to pick the pocket operation, and in here it's exactly the same as the face milling operation. I can go and pick geometry I want by picking edges, or in this case a face, and gives me a preview of what I'm going to use. For the tool, go in and pick a 10mm end mill. As you can see, you quite quickly get this just by a double click. Once this is selected, it'll give me a preview on my mouse or on the side if need be. And I can go in and set the pocket depth if needed, but this has been picked automatically, as well as the step down. You can see I can change the overlap of the tool as well, and whether I want to start from the inside or outside, and of course adding those fillets to reduce the tool load. As you can see in the background when I've pressed calculate, it gives me the tool path as well as the updated stock that I might want to have. As you can see from the updated stock, there's some areas of material I haven't been able to clear with the 10mm end mill. So I've used an option called Save and Copy to copy the exact same toolpath, in which I'll change the 10mm end mill to a 4mm end mill, and then we can go and look at those rest areas. From there, you can see it's taking all the same information that I had previously. And as I select rest material, it'll ask me to define the tool. I could pick the previous tool, or I could just add the diameter like so, as well as the previous wall offset, so it knows where to look for this material. I'm going and pressing save and calculate. You can see the toolpath is immediate, and we can see there the updated stock is going to take out those areas. Let's move on to the profile operation from here. The profile operation is a great way to finish off the interior of this pocket. You can see I want to get the walls, so I've picked the contour that I had previously. I can then go and select the tool that I want, and again I'm going to use the 4mm end mill. I can pick the levels I desire. This time I've done this manually. And then from there I can go to the technology, set how many finishing passes I want, as well as a step down to suit. Finally, I can see that I might want to move the start point of my toolpath. In here, I can do that simply by just doing it by shift of 1%. Once that's done, I can go through and calculate the job and then check my toolpath. As you can see, once saved and calculated and simulated, the toolpath is now going around the edge of the job as we expected, and going to clear up any of the stock material that is left, leaving me the finished component inside. So as we can see, as I go and put updated stock on this material, the inside of this job is now cleared up really nice. And we're going to have a look at the last operation for today, which is drilling. With drilling, really simple. I only have to pick a face and it picks the holes for me. Then I can go and get my spot drill to start spot drilling all the holes that I want to machine. And you can see, with just a double click, I have my spot drill, and I can set a manual depth to how far I want that spot to be. And whether it be the cutter tip or the full diameter, you can see it'll always pick the shortest distance, and I'm just going to set it so it's not going into a pecking site. The toolpath's been created, and that's looking great. What I can do from here as well is copy that toolpath like we did previously, And in here, I can then set my tool to the 1.78 mil drill to get the drill holes that I desire. Again, in here, I could pick the levels. And since it's a through hole, I'm just going to select to the bottom of the target, which it'll do for me automatically with a full diameter. Again, I could go and put a G83 cycle, and in the dialog box, I can check what step down I want this particular tool. From here again, I can save and calculate the toolpath, as well as simulate it if need be. As you can see, the updated stock is showing exactly what had happened to the part, and we could use the SolidCam simulator to verify how the toolpath is going to go through the part, as you can see, pecking down each hole one at a time. With the end of that toolpath, that completes our look into SolidCam 2.5D, and I hope you've enjoyed it.
Mana kichik prezentatsiyamiz ham tugadi. Demak, mana shu dasturlardan ko'rib chiqqan bo'lsak, ana shu birinchi holatda demak, CAD dasturlarini, KE dasturlarini va CAM dasturlarini ishlash qobiliyatlari va ularning ustunlarida aytib o'tilgan edi. Endi bu dastur mahsulotlarni har bittasi bo'yicha punktma-punkt mana shu yerda endi ikkinchisi, birinchisi AutoCADda, yana qolgan programmalarda chizmalar chizishdagi simida ko'rsatib o'tilgan bo'lsa, ikkinchisida bo'lsa SolidWorks tizimidagi uch o'lchamli bo'lgan jismlarni yig'ish jarayoni, ya'ni zborka deyiladi. Ana shu jarayonlarda ko'rsatib o'tilgan dasturlar ko'rib o'tildi. Bularni keyingi ma'ruza darslarimizda juda ham chuqurroq o'rganib, har bitta dastur bo'yicha ko'rsatib o'tamiz. Endi asosiy dasturiy mahsulotlar bu dastur yoki mantiqiy bog'liq dasturlar to'plami hisoblanadi. Ma'lumot tashuvchilarda qayd etilgan sanoat ishlab chiqarish mahsuloti bo'lishi, dasturiy ta'minot hujjatlari bilan ta'minlangan, sotish yoki bepul yoki boshqa bir usullar orqali keng tarqal ishlash uchun mo'ljallangan hisoblanadi. Tashkiliy tizimning asosiy elementlari quyidagilardan iborat bo'ladi. Demak, ishlab chiqarish, marketing va sotish, moliya, ma'lumot, kadrlar, inson resurslari, tizimni tashkil etuvchi sifatga ega boshqa barcha resurslardan foydalanish samaradori ularga bog'liq bo'ladi. Mana shu bugungi demak prezentatsiyamizda asosiy narsalarni aytib o'tildik. Keyingi darslarimizda sizlar bilan ular haqida juda ham chuqurroq ko'rishib o'tishga harakat qilamiz. Keyingi darsimizgacha. Demak, chiqishimiz.